said that there are no like scientific ground about the fossil fuel phase out topic. And actually, it's a pity that I have not enough time to invite him directly to this pavilion, to Ukrainian pavilion, just to hear and to know more about this scientific ground on the fossil fuel phase out from the Ukrainian National Scientific Antarctic Station, named by the Volodymyr Vernadsky, the prominent Ukrainian scientists, and also from the Ukrainian other scientists who are like in the top of the climate agenda of the world. And I want to pass the floor to Svetlana Krakovska. Svetlana Krakovska is the head of the Laboratory of Applied Climatology at the Ukrainian Hydrometeorological Institute of the National Academy of Science of Ukraine and the National Emergency Service of Ukraine, which in 2022 was recognized among the top of 10 most influential people in science by the Nature magazine. So, Svetlana, please, the floor is yours.
Thank you so much, and thank you for all who actually come to our event, to this very important event, station. And the science actually, as we see, says that Antarctica is one of the most vulnerable places on the Earth. So I just want actually, I want to say that here I am, I'm now in history, in fact, I understand. And I want to start to speak about history of our station as well, because it was very long ago for many of people, young people who are now actually really worried about climate change. But for me, it was like yesterday, in fact. So this beautiful surrounding you see here, it's surrounding of our station, and it is now different with what I saw there when I was in the second Ukrainian Antarctic expedition in 1998. So please, yes. So this me. I was young. I was, as most here, young people who want to go to Antarctica. I climbed these ice cliffs, and now if you will go to our station, you will not see actually most of those cliffs, and this is really pity. So Antarctica really destroyed. And please, next. So I was meteorologist there, and of course, and now I'm climatologist, and as Ola said, I worked for IPCC, which is Intergovernmental Panel on Climate Change, and here, chapter 1, it's me, just over clouds, and looking to Antarctic actually mountains. So please, next. But a year ago, actually, I just tried to remember how it was here in COP, in Sharm el-Sheikh, when we were at COP27. Just before this COP, we had actually this explosion just near our National Antarctic Scientific Center. It was very hard period, and I remember when I was starting to go, it was blackouts in my country, and it was so difficult, in fact, to survive all this situation. We still have windows, some windows actually closed, not renovated. Well, yeah, it's another part of the story, because on the 24th of February, when life of many of us actually changed, I was head of delegation of actually Ukraine to IPCC, and if you put one more. So at this time, in the first hours after bombing of Kiev, I said that the roots of climate change and actually financing of the war is fossil fuels. So it was clear for me how to connect both these problems, and it was really viral, I would say, because it was in all media. And I'm really happy, in fact, year after, to listen about this treaty of non-proliferation of fossil fuels. So I really wanted to come to this COP because I want to see how it will go further. And I really hope it will just accelerate. So please, next. Yeah, okay. Yeah. So this resulted in what already said, that I was selected for this Nature top 10. Please next. My story was Voice for Ukraine, of course, because I was talking about Ukraine and fossil fuels a lot. Please next. And this is exactly what was about science a year ago in this Sharm el Sheikh pavilion, in our first in history pavilion. We were talking about accelerating science-based green transition in Ukraine. We still want to make it even bolder. Please next. So now we go to actually Antarctica, particularly Antarctic. So since we have this station, please next, we had few national programs, in fact. So we started from the year when we got the station from British Antarctic Survey. So it was our first program in 1996. Then we had the state program till 2010. And now we are on the third program, which now actually extended till 2023. And we are about to have this act of the government on this National Polar Research Program. So we have a lot of input to very high level scientific work for Antarctica. Please, next. So our current state program includes few actually our branches, let's say. One of them, you see others: geological, geophysical, biological, medical, physiological, oceanographic, new technologies. But since I'm going to talk here about hydrometeorological research more. Please, next. And this actually our research, we have now a new journal. You see it here, actually. This first our journal, which is about Antarctic research, and it's now in Scopus. So it's really high-level journal, and we invite other scientists to be with us and to publish your papers in this journal. And many of our new research now there. I invite you to to actually to join us. And here on the middle, you see the team of meteorologists who made first ever Ukrainian launch of radiosonding on the station. And one of them is here with me. It's my student, Anastasia. She will talk more about this. So please, next. Well, about Vernadsky and the team, now we will see more, I guess. So this is some history which I already talked about. The station started before Ukrainian. That took actually the station in 1947, and the station has actually one of the longest uninterrupted measurements, meteorological, climatological measurements. You see the region, and as you see these pictures, is beautiful. It's one of the best places in Antarctica for many visitors, in fact. Please, next. So usually our team during the winter, it's from 12 to 15 people, but during season we have much more people, up to 40, as far as I remember. And we are really proud that we now have this new ship, research vessel, Noosphere. Actually, we got it, if we go next, I guess we will have more on this ship, beautiful ship. Actually, I should say that this is this research vessel. She took the first expedition, Ukrainian expedition to Antarctic station in 1996. And then 25 years later, we've got the same vessel from British Antarctic Survey. We bought it, our National Antarctic Center. And now we have this very good, very well-equipped actually tool to continue our research and to extend our research. We go next. So this ship actually has, of course, it's famous. It was built in 1990. So when I first saw this ship and visited, it was very new, but actually I visited before She left to Antarctica in 2021, and she was still very, very, very nice and very good actually condition. Please next. So we can do research from oceanography, deep oceanography, in fact. So we plan a lot of other research. We still, of course, it's very difficult now to do in the country which is in the war, but we still we understand that Antarctica is one of the places where we are on top actually of the international science, and we really want to collaborate more. Please next. So if we speak about climate on the Antarctic Peninsula, actually I visited one of these mountains. We can go next. So why it is important, of course. We know some tipping points. It's a very recent paper, and one of these tipping points, it's exactly Antarctic Peninsula and ice sheet. And here we speak about clouds. And so now I will I pass my mic to my young colleague, to speak more on clouds and precipitation, because I guess it's her topic now.
Yes, thank you, Svetlana, for this. Like a few words about the green restoration of Ukraine during the war, and like in a post-war recovery, also towards to the European Union green agenda and accession process. Thank you, Victoria.
Дякую, Ольга. Насправді, хочу відразу сказати, що мені дуже приємно бути на цій панелі, тому що, ви знаєте, це літо, цей рік був один з найжаркіших за останні періоди. І ми страждали з вами, що в нас там температура піднімається на 5 градусів, на 6, коли ми звикли до більш комфортного. Але мало хто розуміє, що ці всі підняття температури саме впливають на зміну нашого, що ці температури випливають із зміни клімату, і що в деяких місцях ми втрачаємо водний баланс, ми бачимо танення льодовиків, так, і насправді це дуже критично. І на цій конференції, саме на конференції КОП-28, дуже активно говорять саме про підвищення амбіцій, про підвищення плану досягнення своїх кліматичних цілей, тому що зараз світ відстає, світ не встигає, світ не виконує свої зобов'язання, які він взяв на себе по Паризькій угоді, і ми, як Україна, в свою чергу, теж повинні бути в цьому порядку денному, і в першу чергу на порозі нашого такого стану, коли в нас йде війна, а ми вже з вами говоримо про відбудову. Ми вже розпочинаємо нашу відбудову. І яка відбудова повинна бути? Вона повинна бути тільки зелена, тому що ми зараз закладаємо майбутнє України. Ми зараз закладаємо не тільки майбутнє України на території, а саме майбутнє Європи, тому що ми повинні з вами показати приклад, як можна відбудовуватися з кліматично позитивними проектами. Ми повинні показати, як ми з боротьбою з pollution переходимо до боротьби з emission і впроваджуємо найкращі заходи. Тому що зараз я дуже задоволена, що на конференції КОП саме в нашому павільйоні ми обговорюємо відбудову, ми обговорюємо високі теми, саме кліматичні теми, і не забуваємо, звичайно, що війна і ця проблема не пішла від нас, ми з нею боремося, але ми на сьогоднішній день вже плануємо наше майбутнє. Тому ще раз дякую всім присутнім, дякую панелістам і дякую, звичайно, хто у нас підключений онлайн. Передаю там окремо привіт. На жаль, зараз не бачу, але ще поспілкуємося. Дякую.
Thank you, Victoria. Yes, and now I'm passing floor to a junior researcher at the National Antarctic Science Center of Ukraine, specializing in atmospheric physics and geospace, to Anastasia. Yeah,
Thank you.
yes, and also you can just continue
Yeah, sure.
describing our contribution.
And coming back to Antarctica and basically what's going on there, why it is important, basically because polar regions are drivers of the global weather, and clouds could cause basically a lot of warming. In fact, we don't know till the end how they will impact. Clouds and precipitation can do both, like melting and freezing. So studying on these topics is really important now, and we try to do this. Please, next. So when we talk about climate change in Antarctica, for our perspective, it is Antarctic Peninsula. What are we thinking about usually? It's temperature, mean temperature extremes. But if we will take a look a little bit in different perspective, we will see precipitation, and precipitation phase will change. So change of liquid precipitation will increase. And temperature regime, if we will talk about ice days, is basically based on maximum temperature, daily temperature that is higher than zero, lower than zero. So number of these days is getting shorter. So less days during the year with basically zero temperature. And it is over the glaciers. So does it tell us? That basically we have a lot of melting ahead. And on the Western Antarctic Peninsula, it is more liquid phase, and that affect more melting on the coast, and it is less on the Eastern Antarctic Peninsula. Please, next. Antarctic Peninsula changing weather, like examples, how it's look like in real. So extremely warm winter in 2022. Basically, it was minus below freezing, so more moisture in the atmosphere, more precipitation, and more snow record. So we have really a huge snow record. Please, next. And when we have average annual high of the snow about 2 meters, please, next. We have snow depths in 2022, it's 3 meters 45 centimeters, so it really was huge. And next. We had snow drifts up to 10 meters, so basically our station building was covered with snow and with penguins, because it was kind of easier for them to get on the roof. And you can think that such event can be examples that everything is fine and we will have accumulation of snow and basically we shouldn't worry about anything. But this winter already show us that we have record-breaking temperature on July during the winter, like +8. So please, next. Such moisture intrusions from Pacific Ocean is nowadays defined like atmospheric rivers, because it is long intrusion from mid-latitudes of atmospheric rivers that caused a lot of humid, warm, rare rain that faced Antarctic Peninsula like perpendicular, that caused a lot of precipitation in the eastern, western, and northern Antarctic Peninsula, and it is caused a lot of damage there during these events. It could be during the warm season, it could be basically rain during all event. That's make a lot of melting process. So next, please. Oh. Wow. Sorry. And next slide was basically about how huge damages, I think so. Next slide. So how this atmospheric river basically could be, looks like. It is a small event over the April 2021. The left, it is rain phase. On the right, it is phase with clouds, rain, and we can study different particles of the precipitation during the event. Please, next. And when we have precipitation over the Vernadsky station on the Western Antarctic Peninsula, what we have on the Eastern Antarctic Peninsula? So basically we have huge Föhn effect that is basically warming. It is could be around 0 or +2 degrees over 1 kilometer on the Western Antarctic Peninsula over the Vernadsky station. But on the Eastern Antarctic Peninsula, where nowadays we have like damages and destroyed glaciers already, it could be around +6 in a layer up to 1.5 kilometers. So it is really warm as for Antarctica. Please, next slide. And from Vernadsky station, unfortunately, we can, despite the great view from Vernadsky station, as you can see, we can basically see this damage in real time. So from Vernadsky station, we can see these huge glaciers, and as for like our simulations agree with our observations that it is caused a lot of damage. So next slide, please. And this is how it could look like typical summer in Antarctica. So a lot of glaciers filled. So it's like a huge building, 9, 10 floor, even more. And you just have to like navigate around this. So when we talk about intense precipitation event with snow, 10-meter drift, and it is not enough to balance such kind of melting and such kind of damages. And that is why basically when we talk about climate change in Antarctica, that is what we call irreversible climate changes. So next slide, please. And from what we have to assess climate changes nowadays, it is climate models. And from climate models, we have a lot of warming, a lot of decrease in frost and ice days, a lot of rain in Antarctica. And even nowadays, you can see the nearby penguins, you already can see a lot of green. So next slide, please. I finish in my talk. I would like to say, first of all, thank you to all our army defenders that on the front line now. And of course, we would like to thank you to all the international communities that during these 2 years support us. And my takeaway message is climate change is really in progress now, and it is very aggressive, but even more aggressive is war in Ukraine that we haven't started, and we will fight, we will continue to fight, and we will still need your support. It is our guys who did a lot of great studies and work in Antarctica, but now they have to stop working on it, and they spend their time and risking their life in Antarctica, and it's not all of them. So thank you. And next slide, please.
Thank you, Anastasia, for this very crucial speech. And can I just summarizing something? So you said that we have some temperature records or anti-records like last year and this year from 1958.
Yes, absolutely. So it is really, I think Svetlana can say more about the temperature records.
Well, I can tell more about actually trend because, well, until the end of the 20th century, actually our station was one of the hotspot where warming was the most intensive on the Earth, in fact. So actually we were in the hotspot, this Vernadsky station. So that's true.
Yes, thanks for this clarification, because I think that's like huge that we had like a lot amount of this temperature records, not like on our hometowns, but also in Antarctica, like the warmest winter, like the highest temperature, like in winter, and average annual temperature. So that's really huge. And now I think that we can go to our participants online from Antarctic Vernadsky station, who will just reveal us the latest contribution from Ukraine to world climate policy and science agenda. Yes, so we are glad to. Can you hear us?
Good afternoon.
Good afternoon. Yeah. Great.
Yes. All right. Just wait a little.
So we can hear you well, and you can just start. So
Okay.
yes, I am passing the floor to Dmytro Krachun and maybe Vadim Tkachenko, who are the meteorologists and biologists at the Ukrainian Antarctic station Vernadsky, like who will enlighten us about the latest climate scientific agenda too.
Do you hear me well just right now? I don't hear you.
Yes, we can see that slides. Everything is great.
Okay, okay. Today I'm gonna be alone. So good afternoon. My name is Vadim Tkachenko. I'm a marine biologist, and this year I'm a participant of 28 Ukrainian Antarctic expedition. So today I'm here to share the weather anomalies observed by our researchers over the last 2 years at the Ukrainian Antarctic station, and to tell a little about how it impacts on wildlife. So, okay, 20.7 degrees Celsius. This temperature record was registered at the station in February 2022. The previous record was in 1985 at plus 11.7 degrees Celsius. Anomalous temperatures were also noted at other Antarctic stations on King George Island, located north of Vernadsky. And as Anastasia mentioned, and as all you mentioned, yeah, this was absolutely crazy point. 8.7 degrees Celsius on July 3rd, 2023. We recorded the highest July air temperature in all years of observation. The previous highest value was plus 5.6 degrees Celsius in July 1965. And I remember on July 5th, we got message from Colin Wright from British Antarctic Survey. He asked, is everything okay? Is everything works well? What's going on? Because he also got this record, and all we can say to him that we're just melting and everything okay. So in Antarctic winter of 2022, in our station region became the warmest in recorded history, as also was mentioned, with an average temperature just slightly below -2 degrees Celsius. And minus 13.8 degrees Celsius. This temperature marked the coldest day of 2023. Previously, this indicator ranged between -15 and -30 degrees Celsius, with a record of -43.3 in 1958. So a new snow record observed in November 2022, almost half a meter more than a previous maximum. This is remarkable given the recorded 3 meters in December 2021 were also record breaking, surpassing the 2.65 meter in 2016. Due to a warm winter, the atmosphere holds more moisture, leading more intense precipitation. This is one reason for the observed snow accumulation in the West Antarctica. Okay, and about sea ice. During the austral winter of 2023, we observed a decreasing of sea ice around the station, and the stable ice cover that usually bends the sea around our island did not form at all. This is due to another anomaly, a local warm current that appeared along the Antarctic Peninsula. And the National Snow and Ice Data Center in the United States alarmed, because according to this winter, the sea ice level around Antarctica is much lower than any previously recorded winter level. On this slide, you can see a panorama from Biscayne Bay, and actually it's really hard to get to Biscayne Bay In previous years, it was completely packed with ice, and it's also really far from the station. So you need to go far south. You need to go 20 kilometers south and then turn left. But this year, it was pretty easy to get there. And in November, we made three expeditions to Beskid Bay, and it was something very unusual. Okay. What about impact of decreasing of sea ice level? In 2023, the reproductive season of Weddell seals was complicated due to a lack of ice. This pagaphilic seals mostly give birth on sea ice, rarely on land, if there is a convenient shore without steep descents. So channels and creeks between Argentine islands often totally frozen during the winter period, and this is an appropriate place for Weddell seals breeding colony, which often forms in the end of August. But this year, these creeks and channels, they did not freeze at all. So for breeding colony, it was really hard to find a place to give birth to their pups. Another pagaphilic seal was affected. For example, Probita seal is very common for our region, but in winter 2023 it was so iceless that we recorded a significant decline in the number of Probita seals during the winter period. It was about 10 times. So we often have 600, maybe 700 encounters of Probita seal during the winter period, but this year we got only 54. So it's a significant decrease. And another fact is penguins advance. So due to the open water around Galindez Island, where Vernadsky station is located, in 2023, Gentoo penguins returned to the breeding sites much earlier. It should be mentioned that until 2007, these penguins did not nest near the station at all because of late freezing on the water around Galindez Island. So penguins often were moving far north to spend the winter period in better ice conditions. But during the last 5 years, with the warming in the region of West Antarctic Peninsula, Gentoo penguins moved south. From 2011 to 2022, the number of Gentoo penguins nests on our island increased more than 6 times. And by the end of the reproductive season, the total population of these birds now is about 6,000 individuals. Another important thing about Gentoo penguins advance. This year, we can say that at least 7,000 Gentoo penguins didn't leave the region of Kiev Peninsula, and they successfully spent their winter feeding in open water. So we think this is the reason why Galindez Island and Petermann Island in the middle of September were already settled by these penguins. And one more fact is the increasing number of penguins on Galindez Island and on the other islands. The landscape began to change rapidly. The expansion of Gentoo penguins leads to the accumulation of significant amount of guano. This process is essential because when due to the next cooling, penguins will retreat, and the organic matter will give rise to a new, even more diverse community of Antarctic plants, mosses, and 2 vascular plants. So I think this is all for today from me. Maybe you have any questions.
Thank you, Vadim, for publishing and releasing this new scientific facts. So we have like 12,000 kilometers of distance, but we understand that these climate change issues concerns us, concerns the Antarctic island, and that is like maybe not so obvious because like in Antarctic we do not have cars, transport sector, industry, we do not have like coal power plants, so we can only imagine how this effect just multiply to our home cities and towns. And actually that is totally not about the penguins. We need to understand this. That is totally also totally about us and our parents and our children. So thank you for your work. Thanks for this presentation one more time. And I want additionally to thanks to the National Scientific Antarctic Station for supporting the reforms and Green Deal agenda in Ukraine, because you supported the industrial pollution reform, the 75 directive. So thanks a lot that you're on the side of nature, flora and fauna. Thanks a lot. And now I want also to pass the floor to Yulia Vostavna. So she's an isotope hydrologist from the International Atomic Energy Agency, and she will tell us more and maybe also present some facts about the impermanence of the permafrost, which is currently undergoing significant thawing. So, Yulia, can you hear us and can you contact us?
Yeah, I can hear us. Hello, do you hear me? Here? Do you hear me?
Yes, we hear you well.
Great. It's good. Congratulations, this is event. This is really impressive what you did. I followed all your presentations. There are a lot of things even I knew what I learned and never heard about that, like change in ecosystems, because Antarctica is very far from us. But last days in Vienna, we have -11. I never faced with this temperature, and we have snow like 30 centimeters. So it's remind me, I'm happy, quite not all inhabitants happy, but I'm happy because it's remind me a little bit my native city. Now it's hero city, Kharkiv. So a little bit of Antarctica we have now in Vienna. So I hope I will meet you next days in person, but let me to start with the presentation and to review you some world of isotope hydrology a little bit and contribution Antarctica to our research and knowledge. Can you put my presentation, what I shared it, please? If it's... No.
Yulia, you can just take your host credentials and
because I
publish
cannot
it.
share screen. I cannot share screen. Okay, it will be gray, but
okay. So we maybe have another presentation then.
No, I can share. Do you see my screen? Can you see my screen now?
Yes, it works. Yep.
It works. Can I continue like that?
Yes, you can continue.
So, just because okay, because actually Zoom is not our native system. Okay, so let's me to continue just a little bit about isotopes. What mean isotopes? Isotopes, it's mean what we have elements, but able to integrate a lot of memory. And if you look at isotope of water molecules, it's integrate memory about temperature, about precipitation, about even ecosystem change. But our task to understand what information we can get from various isotopes. Here I will talk a little bit about stable isotopes, moles, and radioactive isotopes, and we are always focusing on natural isotopes here. For example, we have record of isotopes in the world, and the longest what we have, it's in Antarctica and Vienna and 2 more cities. So congratulate Antarctica with the longest isotopes records in the world what we have, and those records are not interrupted. So thanks to you and also previous colleagues who was able to collect very essential data. What isotopes show us? Isotopes show us how air masses changes, what was the reason of those changes, and generally, as I told you, they integrate memory. So they're really not like if you measure temperature, you measure just temperature. If you measure precipitation, it's just millimeters of precipitation or snow. But here the isotopes integrate everything. It's actually like essential of all changes in the system. That is why in our agency, we have a global network of isotopes and precipitation. It's about 60 years of time series data through the world. They use not only actually for climate research, they use a lot for food research, for arsenic sites, for paleo research. And now this data is growing, and we start to use artificial intelligence models to process this data. And not only water isotopes, you mentioned about fossil fuel, and we are using also isotopes to trace sources. For example, now we are thinking how we can integrate nitrate isotopes in our global system of observation to understand what amount of contribution from different air pollution sources. We have also agricultural, we have fossil fuel, and we can trace not only the percentage of contribution, but from what they came, from the source, the initial source. It's interesting what it's also greenhouse gas, and also it's transport impacted by natural processes, for example, like lightning. So now we develop already some kind of database, and we are looking further to extend it, to use isotopes also for source tracing. Back to Antarctica. So we are our main station in Antarctica, now it's Vernadsky station, and before it's already mentioned in Svetlana presentation for Faraday stations. We also have 2 more stations what we are covering with isotopes, and we are using this data for a lot on climate models and to understanding different circulation. For example, one of the paper what we did recently, you can see here is Vernadsky station. Actually, you told already much more detailed about how temperature changing, how precipitation changing, but we also look in how isotope is changing, because Antarctica seems to be far from us, from me now, from Vienna, but not in the worst maybe weather conditions like what we have last days, but it has a huge impact on the all climate circulation patterns in the world. So, and because my presentation is very short, as we agreed earlier, why the longest isotopes records in Antarctica important? Because we are using it to validate global climate models for better prediction of future change. We always look at the past to predict something new, but also isotopes compare to other measure meteorological parameters. They integrate much more information. They integrate whole system functioning. Also, we are still a lot of disclosed in our cryosphere, and a lot of now will be revealed in the future. So generally, studies in Antarctica help us not only to look at the future, but also to look at the past. Also, we are looking how the whole hydrological cycle changing. It's in regional, local, and global levels. And the most interesting, but actually, ice from Antarctica is one of our main depleted standard in our analytical measurement and data interpretation. So we are using, actually working with Antarctica daily in our samples calibration and validation of results. Another idea, but we are still developing this tool, and we apply now in some pristine glaciarized area in Italy on how nitrate isotopes can be used to trace air pollution sources derived, because you mentioned different about anthropogenic one, but it also can be natural one. So we are really working, it's only method that actually can help us to trace exactly contribution in percentage and really to fingerprint the source of the pollution. So this is
Okay, thank you.
my short
Thank you.
presentation. Thank you very much. I will pass your pavilion next days on my arrival. Thank you, Svetlana, for inviting me, and big congratulations with this event. Thank you.
Thank you, Yulia, for your huge scientific contribution into this topic. And now we have like some minutes, and I want to pass the floor to Clara Boots, who is a financial campaigner from Urgewald. So we know that Antarctica is almost totally destroyed. So what about Arctica? What about this carbon bombs, fossil fuel projects from Russia, especially, which really cause and deep all of this troubles? So yeah, thanks.
Thank you very much. Before we jump from one from the south to the north, I actually want to say I'm very happy to be here. I also studied meteorology, so I'm very happy now. I'm a financial campaigner, but now I'm very happy to be back as a guest in the meteorological community, actually. So yeah, I'm going to talk about the expansion in the Arctic of oil and gas as soon as my slides are up. And my organization, Urgewald, we mostly work on financial institutions and try to get financial institutions out of oil and gas companies and to really remove these finance flows towards renewables, or especially away from fossil fuels. And one of the regions where oil and gas production is actually expanding is in the Arctic. And here we see Yamal LNG, which is an LNG terminal in on the Yamal Peninsula in the Russian region. And we're going to talk about that more. So next slide, please. So as a finance campaigner, and with trying to really move financial institutions out of fossil fuels, we really need to know the oil and gas industry quite well. So what our organization does is to actually do the research and really look up all the oil and gas companies that are out there. So we came up with the global oil and gas exit list. That lists, you don't see it there, down there, but it's more than 1,600 companies in the upstream sector and in the midstream expansion and the gas-fired power expansion. And we really try to, put an eye to the expansion of oil and gas. Next slide, please. Some of the production, the expansion is actually with unconventional methods, just like fracking, tar sands, coal bed methane, heavy oil. We have, I don't see what the next one down there is. Ultra deep, ultra deep water. And what I'm going to talk about, the Arctic region, which is also, very vulnerable. And so it's, just a very bad region to, extract oil and gas from. Next slide, please. When we talk about the Arctic region, most people talk about the Arctic Circle, which is the black circle that you see in there. But the Arctic Council actually proposes to use the AMAP definition. So that's the definition from the Arctic Monitoring and Assessment Program. That's the red line. And that also accounts for the ecological, physical, and geographical characteristics of the region. So there's so many vulnerable ecosystems in there. And so that's how we define the Arctic, to really account for all of these characteristics. And so just to keep that in mind when I talk about the next slides. Next slide, please. When we look at the Arctic production last year, we had 4 billion barrels of oil equivalent in the Arctic. That's roughly the total production of Total Energies, Shell, and ExxonMobil combined. So really, when we take all of the production of oil and gas majors, that's what we get in the Arctic. Even though these companies are not that involved in the Arctic, we mostly see Russian companies. So we have Gazprom with 2 billion barrels of oil equivalent. That's roughly 2/3 of what Gazprom is actually producing. Then we have Novatek, which is one of the most important companies right now for LNG build out and really driving the war in Ukraine. Rosneft. Then we have the Norwegian Equinor, then again a Russian company, Lukoil, a German company. 2 minutes. Okay. Then please, next slide. And then some other companies as well. And when we look at that from a country perspective, we see that nearly 86% of the Russian production in the Arctic is actually from Russia. And then we have Norway and USA, Canada, and UK. Next slide, please. Also, when we look at the expansion, we see that, again, Russia is the one expanding the most in the region. Please note that the dot and the comma is always another way around, because that's the German notation at the moment. Yeah, but Russia has the highest expansion. You don't see the other countries down there at the moment, but yes, let's go to the next slide. We list a lot of numbers and data, but the most important thing is actually the story behind all of these projects. So when we talk to financial institutions, we always try to sell these stories or to always tell them what the reputational risk is, how the livelihoods of people are actually behind that and really impacted by that. So there's also in the Arctic region a few reputational risk projects. Next slide, please. And yeah, next slide. So it's a lot of birds and wildlife actually involved in there. But yeah, we'll skip these stories because of time. And what I wanted to say is that actually any money or any company that is currently producing or expanding their business in the Russian Arctic region and Western Siberia is not only driving climate crisis, but everyone who's financing that is also financing the war in Ukraine. So we really need to stop that and stop expanding oil in such vulnerable regions as there. Thank you very much.
Thank you very much for this crucial highlighting of this subject, because we know that Russia actually weaponizing everything, language, culture, fossil fuel exporting, and like everything. And Russia tried to build the profitability of the European economy on its fossil fuels. And now Russia tries to do this not with the Nord Stream, but with the LNG technologies. So I want to thank everything who join us, who will also see this video record maybe after the COP28. I think that it's a proof and it's obvious that we need to collect all of our efforts just to stop the fossil fuel extraction in Antarctica and try to save what we just have from Antarctica. Yes, because that is our very important mission, because as I said, that is not about the penguins, not only about the penguins, that is about us, our parents and our children. So thank you, and we need to stop